Scientists now believe that it holds the answer. For Dan Durda, this powdery rock is an indication that the dinosaurs perished in a sudden astronomical catastrophe.
Dinosaurs and 75% of all the other plants and animals that live with them, this layer is their tombstone. This thin layer of clay is the important evidence of a violent event in the history of life on the planet.
The evidence held in the tombstone layer is a huge amount of an exceptionally rare element, iridium. The remarkable concentration of iridium was discovered accidentally in 1980 by a father and son team of scientists, Luis and Walter Alvarez. On the planet's surface, iridium is usually found in very small concentrations. Most of this rare element originates from space rock, deposited from the multitude of small meteors vaporizing in the upper atmosphere every day. The Alvarezes were looking for variations in the strength of these tiny meteor showers, but when they realized this huge concentration was held in the infamous tombstone layer, they proposed a radical new theory for the extinction: death from above. The dinosaur planet had been hit by an enormous meteor. Their theory remained controversial for over 10 years, until the final piece of the puzzle was discovered in Mexico. A hidden crater over 100 miles across.
In 1990, the Chicxulub impact crater was discovered, and its age, when finally dated, turned out to be precisely 65 million years old. It turned out to be, it was the smoking gun for the Alvarez theory.
Worldwide, the tombstone layer contains an estimated 200,000 tons of iridium. This translates to a meteor over 6 miles in diameter. Its impact on the planet would have been devastating.
You've got to imagine Mount Everest flying at you across the sky at 20 kilometers per second. Several thousand cubic kilometers of the Earth's crust were vaporized and excavated and launched around the entire planet, slowly raining back down through the atmosphere to settle across the surface of the Earth as a thin layer of dust and debris.
But the meteor was not alone in wreaking destruction. Today in India, ancient lava flows exist that are so thick, whole temples have been carved into their layers. The lavas were the result of a massive eruption that was occurring simultaneously with the meteor strike. Although not as extensive as the earlier Siberian eruptions, these lava flows in western India could have buried the USA to a depth of over 600 feet. The huge clouds of toxic dust they produced would have rivaled those of the meteor. 65 million years ago, the meteor impact and the eruptions would have been a deadly double blow. Whichever had the stronger effect, the combination of these events sounded the death knell for the dinosaurs. The dust cloud lingering high in the upper atmosphere and blocking the sun devastated the life below. The huge dinosaurs, along with most other major species, were extinct. The new world that was to follow would be the world of the mammals and the world of man. "50 million years ago, life was slowly recovering after the cataclysmic extinction that obliterated the dinosaurs. The Earth had been around for over 4.4 billion years. But only now were the first mammals, our ancestors, beginning to flourish. Long before humans arrived, the continents continued to move and crash into one another. Slowly but surely, the surface started to look familiar as plate tectonics and erosion created the dramatic landscapes we see today. The Swiss Alps. Some mountain chains can be explained by volcanic eruption of rock from the depths of the earth. But the greatest, including the Alps, contain no volcanoes. They appear to have risen as if by magic, up from the plains beneath. This famous range runs through the heart of Europe and reaches over 3 miles above sea level. How was such a huge mass of rock pushed up so high? Adrian Pfiffner is an expert on the structure of the Alpine chain, and he knows the answer.
The scene we see in front of us is the result of a collision between two continents, the African continent and the European continent.
A close study of the Alpine rocks can provide clear evidence of how the mountains were formed. The secret is revealed in quartz crystals that are extremely small.
These slices are about 25 thousandths of a millimeter. At that thickness, you see through one single grain.
The tiny crystals in the rock reveal massive deformation.
The quartz grains have been really stretched, elongated and flattened. You need large stresses in order to deform these rocks. One process that is doing this is actually the collision of two continental plates.
For the last 45 million years, as the continents have continued to move, the African plate and subplates have been grinding into Europe. The continental crust along the collision point experiences extreme pressure, and the solid rock itself is warped and buckled.
If you assume that my hands are two plates which are squeezing the rocks in between, you can see that some of the material escapes upwards and leads to the building of a mountain chain.
The twisted folds of the rock strata are exposed as the mountains are slowly squeezed higher and higher. One famous alpine mountain demonstrates clearly this collision of the African and European continental plates. The Matterhorn. The Matterhorn is the child of two continents.
What's amazing about the Matterhorn is the top pyramid of the Matterhorn is a piece of Africa, and it lies on Europe.
In the formation of this classic mountain, the two continental plates have actually overlapped.
You can think of a car crash. If two cars crash with each other, maybe one car slides over the other one. The two continents moved together, and Africa moved on top of Europe.
Plate tectonics are responsible for all the Earth's mountain ranges. And over millions of years of growth, the only thing that has stopped them grinding inexorably skywards is erosion. Erosion by snow, wind, and rain.
This is the action of water that is eroding the mountains. Now this might seem to be something very small, but actually if you look at the entire Swiss Alps, 50 million tons is eroded every year, and this corresponds to a small mountain roughly 1,000 meters high, one every year.
The height of mountains around the world are determined by these two opposing forces, uplift and erosion, changing them by fractions of an inch up or down each year. But plate movement and water erosion can also create the opposite of a mountain. Under the right conditions, the surface itself can be cut away, sometimes spectacularly. The Grand Canyon, over 1 mile deep, 10 miles wide, 277 miles long, and still growing.
One of the great stories of exploration is when the first Europeans saw the Grand Canyon in the year 1541. And a couple of those men came over to the rim. They saw the river down below and they thought it was 6 feet wide. The explorer sent a couple of his men down, and they came back later and said the canyon is deeper than it looks.
Wayne Rainey is an expert on this geological phenomenon. Its unique scale, the consequence of titanic forces of nature. Over the course of the last 6 million years, this spectacular canyon has been carved by the slow, winding Colorado River, in combination with dramatic uplifting of the Colorado Plateau. Plate tectonic processes have pushed the whole plateau upwards. It now lies over 8,000 feet above sea level.
This uplift probably occurred with the Pacific plate coming into the North American plate and wrinkling the crust, much like if you took a throw rug on a hardwood floor and pushed it along the hardwood floor. When the edge of that rug reaches the wall, you'll see this big bow up in the rug, and that's exactly what's happened to the western edge of North America.
The river looks too small to cut a canyon so deep, but its height above sea level means that the force of gravity gives it great power.
All you have to do is look at big rivers like the Amazon or the Mississippi. They have much more volume of water than the Colorado River does, and yet they don't cut large canyons because their landscape is not elevated. So uplift brings the rocks into an elevation where the river can then saw down through all of those layers and create the canyon landscape we see today.
Plate tectonics combined with erosion have sculpted many of the features on the surface of our planet. And as a general rule, the most jagged, tallest peaks and the deepest canyons are the youngest of these grand structures, all formed within the last 50 million years. But the final touches have been added by yet another major force of nature. 2 million years ago in East Africa, ancestors of modern humans were taking their first steps on Earth. At the same time, down from the North Pole, enormous icy glaciers began to descend. The Earth was about to enter the Ice Ages. Two million years ago, ancestors of modern humans had begun to spread out of Africa. But the Earth around them was cooling down. Before long, much of the planet would be coated in huge glaciers.